Hey everyone, and welcome to this explainer. You know, we interact with screens and devices literally every single day, but have you ever stopped to wonder how we actually tell a piece of metal and silicone to do what we want? Well, today we're exploring the foundations of digital language, and we're looking at exactly how we bridge that massive gap between human intention and machine execution. Let's get into it. So here's the core question. How do you actually speak to a robot? I know, it sounds like the setup to a sci-fi movie, but it's actually a deeply practical problem that engineers and creators deal with constantly. Think about trying to get a machine, let's call him Cody the Robot, to understand our very human intentions. You can't just walk up to Cody, tap him on his shiny metallic shoulder, and ask him to kindly walk across the room. Actually, scratch that. You could ask him, but he wouldn't have a clue what you're saying. There is a fundamental disconnect between what's happening in our human brains and how the machine actually operates. Okay, let's dive right into this. Part 1. The human-machine language barrier. To really grasp how we command these machines, we first have to recognize the giant roadblock standing in our way, and that is, human speech simply does not work on machines. They are entirely deaf to our spoken words. On one side, we have everyday human speech, like English. It's fluid, it's kind of messy, it's full of slang, and it relies heavily on emotional context, right? But on the other side, we have robot speech, which consists entirely of code and symbols. It is rigid, highly specific, and totally literal. We are essentially trying to speak poetry to a brick wall, and it just won't work unless we completely change our approach to communication. As our source material perfectly puts it, computers don't speak English. They speak code. It really is that fundamental. If you've ever watched those super dynamic, high-energy tutorials, like the ones from the coding train, you recognize this paradigm shift immediately. It is an entirely different method of expression. If you want to direct the machine, you gotta drop the English and adopt the code. Which brings us right to our next section, a new symbolic alphabet. You know, people so often think of programming as this incredibly intimidating, math-heavy endeavor that's reserved only for certified geniuses. But what if we reframe that? Think of mastering code as simply learning your primary alphabet all over again. Just as arbitrary squiggles on a page represent sounds that chain together to form words, coding relies on the exact same foundational mechanics, just for a digital audience. We are taking a deeply complex concept and grounding it in a universally relatable human experience. It's learning your ABCs. So, the crucial point here is that computers rely entirely on what our sources call structured symbols. Instead of using the English letters A, B, and C to spell a word, we use these specific, non-human language formats to build literal instructions. These structured symbols act as our new letters. They are the absolute foundational building blocks necessary to assemble commands that a computer's processor can digest and understand with zero ambiguity. Now, you might be wondering, okay, so why does mastering these symbols actually matter for me? Well, it builds what we call technical literacy. Mastering these symbolic alphabets gives you the foundational knowledge to navigate our modern tech-driven world. It's not necessarily about becoming a professional software engineer. It's about deeply understanding the language of the tools you rely on every single day. By grasping these symbols, you are quite literally learning how to read and write in the digital age. All right, let's see this in action. Section 3. Commanding Cody the Robot. Taking all of this abstract language theory and bringing it into physical reality, that is where you see the true power of this new alphabet. It's a 3-step process. It always starts with human intent. Say you want Cody the Robot to wave his arm or roll across the floor. You then translate that human intent into symbolic instruction using your new digital ABCs. Basically, you write the code. And finally, step 3, Cody processes those structured symbols and performs the physical action. This step-by-step sequence perfectly illustrates that incredibly complex relationship between what we desire in our minds and the final digital execution. And this brilliantly illustrates our main takeaways. Programming is fundamentally a specialized language. It completely leaves English behind, acting as a primary alphabet to bridge the gap between human and machine. And ultimately, those structured symbols are the exact tools that allow us to direct the physical actions of our devices. Treating code as a language perfectly resolves that initial disconnect we talked about at the very beginning. Which brings us to one final, exciting thought to leave you with. If coding is just an alphabet, what world will you build with your new ABCs? Once you understand the basic mechanics of this digital language, you quickly realize that the only true limit is your own imagination. You have the power to write the instructions. Thank you so much for joining me for this explainer. Keep learning, keep exploring those symbols, and I'll catch you next time.